Hello there, and welcome back to another episode of Cloud with Chris. You are with me, Chris Reddington, and here we talk all things cloud. Now, thank you for joining. We've got a different topic today, actually. I guess sometimes you think about architecture, you think about the design, you think about the requirements that you need to go and adhere to, etc. But when we've actually deployed that service, that application into production, we need to get a view in terms of how that system is performing. And typically, we think about monitoring, we think about logging, but there's really been an evolution in this space over the last few years into this world of observability. And it's a really important topic, especially when we think of cloud applications where they're distributed architectures, there's different systems or microservices which are processing different aspects of our solutions. It can be really hard to get this right. It can be a real challenge. So that's what we're going to be talking about today. So I am delighted to be bringing to the stage here Samir Pradkar. Hey, Samir.
Hey Chris, hello, how are you doing today?
I'm good, thank you, sir. How about yourself?
I'm good as well, thank you.
Good, good. Let's start with introductions, I suppose. So, who are you? What's your background, and why this topic?
Sure, Chris. I'm Samir. I'm an enterprise architect, part of the digital group within Atos. I primarily lead pre-sales for large deals for my practice. I'm
Mhm.
also a distinguished expert in modern applications domain, and I provide
Sure.
architecture and technology leaderships for Fortune 100 customers. So that's my brief background. I have about 20 plus years of experience in the ICT industry, and some of these topics, and one of the topics which really excited me all this way was observability, because
Mm.
as a software developer, we typically had solutions or systems which are not as advanced. And if you see the kind of systems that are getting built, that are getting deployed, the complexity of those systems have really gone up. And I think the nature of it has also become very kind of a distributed, and with so many nodes, so many, let's say, edge points, so many content delivery networks, etc. I think it has become more and more complex. So definitely, it's an interesting and exciting topic for me. And to tell you, Chris, I've been sort of invited on various forums to present these topics in the last couple of months. So I think this is probably about sixth or seventh time I am actually getting into a discussion to discuss observability. But yes, I'm pretty excited to discuss this on this platform, Chris. Thank you for inviting me.
No, super, and thank you for being here. And I think you mentioned in that intro there as well that the applications we're building aren't getting simpler. They're distributed, and I think it's not just the, let's say, the architecture, the technical capabilities that are getting harder, but I think as end users, when we think of all the platforms that we use day in and day out, we actually expect more from them. I think whether it's our internal tools, whether it's our favorite apps on our phones, for example, we expect them to be available for us. And if they're not available, then you know what? If it's an app on my phone, I'm probably just going to go to a competitor and go try something else out. So, observability is such a huge, important part of this because we need to make sure the system's available for our users and we're giving them that value that they expect. So, yeah, looking forward to it. So, where should we start? I guess maybe, I guess for some of the listeners who are maybe listening in right now, maybe it might be worth just thinking about monitoring, observability, what the differences are, and maybe setting the scene there, perhaps.
Absolutely, Chris. I think, look, I think from what we used to leverage as part of our tooling stack, let's say way back in the earlier days, we used to basically, let's say, bring up the task manager to understand what are the thread counts, what are the process counts, what are the errors
Mhm.
happening, exceptions, thread counts. So these were the basic things that we looked into. We
Mm.
analyzed to, let's say, debug our applications for various things, let's say performance issues or scalability issues, or something going haywire, right? Those systems were still, as mentioned, they were still probably very, let's say, very linear, very
Mm.
in terms of, let's say, kind of a monolithic sort of solutions, where
Sure.
we didn't have a lot of let's say nodes, or a lot of, let's say, it was not really a kind of a distributed kind of an
Mm.
architecture. And but I think we still leverage those tools, maybe task managers, maybe some debuggers, maybe you also had things like making sure that you can basically get a trace of your call stack, etc. What are the APIs getting invoked? What's happening in your application? So those were the early days, Chris. Over here, what we have today and the systems that we build, I'm sure they are cutting edge systems. It really depends on what kind of let's say solution you have, or rather what kind of let's say business problem you're solving, or what kind of customer you're working for. Small to medium scale enterprises might not need a kind of an observability stack, because I think again their solution, their architecture would be limited to only few nodes, only few databases, only few applications. But as you go into the, let's say if you compare the likes of, let's say, the Walmarts or the Amazons or the Googles, right, they have a kind of an architecture which cannot be really monitored using tools that are basically suboptimal. You need to have a proper tool, proper processes in place to do that. So I think that's where observability comes into picture, and I think it has gone through a lot of evolution. So I think definitely there are various generations of observability that you would have sort of seen, or you would have heard of in the past. Some, as I said, it started with basically using primitive tools like, let's say, your task managers or debuggers, etc. And then we had kind of solutions where they would actually had a kind of a dashboard view where you basically ingest data from various servers, various applications, various databases into a kind of a central server, which they also used to call it as the APM, right? Application Performance Management, which basically had a similar, let's say, a capability or services, but they were not intelligent enough to go through it and provide you with the insights of how do you resolve it, what exactly has gone wrong, what are the bottlenecks that you have in your applications. Observability goes a step ahead. It actually provides you with those insights where you can actually make sure to understand what is the root cause, why is the anomaly happening, and what is it that you need to do to correct it. That being said, you also have a predictive analytics capability on that are provided by some of the solutions. So they basically would going through the various let's say data elements that are captured from various nodes, various endpoints. They actually try and analyze in terms of if there's any anomaly that's there in that data, and probably provide you with a kind of a, let's say, advanced warning, advanced alert saying that, look, this is something that needs to be corrected, because I think highly likely it's going to go down. And as you rightly said, Chris, definitely the user experience is something that is very critical in the solutions that, or in the systems that we build today, right? If you have a solution which doesn't really respond in there's an analysis or research done for this particular user experience related solutions, where if you are taking more than 2 to 3 seconds or let's say on your website to load that up, to show all the, let's say, the UI elements, the customer would run away from your site. So that's exactly what these systems are for. You make sure that you have the right elements embedded, right elements integrated into your solution to make sure that the user experience is really not affected. And to be honest, if you have these solutions, some of these solutions are also business critical. So they have a high availability, they have a high scalability requirement, which means if the solutions are gone down, you're definitely going to have a cost impact. You're going to have a financial impact, because you won't be able to sell your products and services on those platforms. So that's also something which is very critical. So user experience being one thing, the second thing is performance and scalability as well. So these are things that are actually sort of analyzed and observed by these solutions, or monitored by these solutions, and it provides you with the right elements of insights, right elements of decision making that you need to do when you actually build these kind of solutions for your let's say enterprise applications that you have.
Gotcha. No, thank you for the explanation there. And I think if I summarize and maybe add some of my thoughts onto it as well, I think this is really driven by cloud, if we think about it, because the applications, the nature of what we're building, typically more distributed, but also now, because of that cloud model, we're able to scale out and scale in our applications. So to the point you made, like the task manager example, and understanding threads, CPU utilization, all these things. Personally, do I care about those things necessarily anymore? Like if I'm getting, I don't know, 98% CPU utilization on my box, in my opinion, that's actually a good thing. I'm paying, I'm getting the bang for my buck, so to say. I'm paying for that CPU that I'm using in the cloud. It's being well used. that's great. But where it's a problem is that kind of multi-layered angle that you were talking about. If the CPU is being absolutely throttled and thrashed, and there's a problem there, and actually there's a load of exceptions being generated on our application, and it's, the application is spinning out of control, that's obviously a problem. So it's kind of taking away the which haystack do I need to look into. It's knowing exactly where the needle is, exactly which haystack, and then saying, right, this needle needs this thread to go and start over again, kind of thing. I like my analogies. Maybe that worked. Maybe it didn't. But
No, Chris, that's perfect. That's the right, let's say, methodology that we have. And as you rightly said, definitely there has to be a CPU utilization that should be really optimum. If you go beyond that threshold, let's say if you go beyond 80, that means you are actually sort of overloading that CPU, which will basically make, eventually basically the application will crash. So you'll have a kind of a rule implemented, you'll have a kind of a notification implemented in your observability to make sure that if it reaches any threshold, you need to basically spawn another virtual machine. But Chris,
yes.
I think to just quickly point out, observability, while cloud is what we are actually sort of advancing towards, and most of these applications are getting deployed and hosted, or probably the cloud native applications are getting built on the cloud itself, we still have that on-premise part or all-premise component to it. So observability is something that actually monitors both these elements. So be it your single cloud, be it your multi-cloud, or also your on-premise, let's say, solutions or applications that you have, which can also be part of the entire, let's say, dashboards or reports that you would basically generate. So that's also included as part of the observability stack. It's a kind of a very distributed and holistic solutions that are built. But definitely, I think it depends. As I said, it depends on the customer that you're working for. If it's a small and medium enterprise, you might not need a cutting edge kind of a solution. But as the solution becomes complex, as you get into a solution which has number of endpoints, number of content delivery networks, and number of edge networks or edge nodes, you definitely need some. You can't actually do it manually. You need to have an automation built into it, which is provided through observability.
Yeah, indeed. And I think that's a good call out, isn't it? That typically you find all of those metrics, those logs, all of that information. And again, you mentioned like that almost proactive analysis as well. That's not something that you can do on a box by box basis or a service by service basis. All of that information lands somewhere, and then you have that single pane of glass to go and observe what is going on in the platform. And so completely valid points. So I guess then that's the foundation. That's what observability is and how it differs. Where do we go from here?
Chris, I think from, let's say, from a solution capability standpoint, definitely, if we have, typically you definitely will build it as an incremental platform, as an incremental capability in your landscape. And observability at some point, it will basically eventually have the intelligence, the entire element of AI ML embedded into it, or AI ML capability embedded into it. Because what happens is, I think while you are actually sort of, let's say, monitoring your entire landscape, you'll probably typically start with ingesting only the monitoring data. So we have matrices, we have traces, all those things will basically be ingested into your observability solution.
Yes.
That actually then goes through various elements of quality checks and quality validation. So it will be basically at some point the raw data will be ingested into the observability data lake. Then you actually do that quality checks, do that quality cleanup, get it into the right level of details that you need, and then it's actually aggregated, which is basically making sure that it's in the right format so that you can derive insights out of it. But the next stage of observability is basically the AI ops, where you have not just the observability data, but also the transaction data, the business related data elements that will actually also be integrated into observability to exactly pinpoint where the issue is. If you have to actually run that entire, let's say, tooling stack to know anomalies, to detect your issues, to basically give you entire predictive capabilities around that. So that's how it is, I think. While it will start with incrementally building, you will actually eventually build all those things into your stack to make it more advanced, to make it more foolproof, to make it more robust. And I think this is basically what we are heading for in terms of making sure that you have all the AI ML things integrated, you have all the advanced capabilities and trending capabilities implemented, so that you have a solution which basically will be making sure that you have you don't have impact on the user experience, you don't have impact on the availability or reliability, so on and so forth. So I think there are 3 or 4 key KPIs and KRAs that are basically impacted by observability. So one of them is user experience. The second one is your reliability, reliability and availability as well. But
Sure.
also this stack will be, you can actually also leverage this stack to find issues in terms of your scalability and performance. As we are rightly discussing, you can actually get notification on your CPU utilization. CPU utilization being one thing, there are a lot of hundreds and hundreds of KPIs that can be monitored. So even that KPIs, you with those KPIs, you will basically be able to, let's say, pinpoint where exactly the issue is. And that's what the observability solution will do for you. So it'll basically give you insights around all those elements, so that in case you have issues with your scalability or your performance, it will basically be able to pinpoint what those issues are, and you will be able to resolve it. So that's where the entire stack is. It's basically a very critical application as part of your landscape. And I think, I'm sure you'll have to, and each of these enterprises who are thinking to build any of these monitoring solutions will have to give a due considerations and make sure that they build things which are actually incremental in nature, and reach a stage where they have a lot of cutting edge and sophisticated, let's say, elements in place to monitor their stack.
And I just want to make sure we really pull it out and focus on it for a sec. I really like what you said about the incremental nature of building up these kind of platforms as well, because I think back in my days where I was doing a lot more cloud-focused work, whereas now I'm more on the kind of actual development DevOps side of things, what I saw as a bit of a pattern and a trend is people would go, right, we're going to take our solution to the cloud, because that's kind of where I worked, but we're going to take our solution to the cloud. Let's monitor everything. Let's turn on everything. But the problem at that point is it's noise. You don't really know what you're capturing, what you're trying to understand, what you're trying to monitor, and what telemetry and insights you're getting. And without first knowing what problem that you're trying to understand, like we want to understand the resilience, we want to understand the scalability, we want to understand the user experience, you're just capturing a load of data. And the challenge, if you do turn things on without having some of that context, is a lot of that could just become noise and then distract from what you're actually really trying to do. So I really like what you said there about the incremental way, start with that initial pieces, build out from that problem, and then grow from there.
Absolutely, Chris. I think what you said is also the way in which we'll have to, let's say, tackle it, because I think there's a lot of data that needs to be synthesized, that needs to be basically made sure that it's in the right, let's say, quality, it's in the right syntax, it has the right semantics. But Chris, I think some of these solutions, if I have to tell you, they actually provide you with a lot of templates, or let's say things where you can actually sort of use those models, data models, if you have to basically relate it to the solution part, right? The technical side of things. So those templates can actually be leveraged in your solution, and definitely you will be able to adopt those templates, the KPIs and the KRIs that we are saying. Those are the ones that are actually sort of ingested into those templates or created into those templates, and you just roll out those templates into your solution. So you are making sure that you once you have those templates in place, you just ingest that data through a data pipeline. So it's kind of an ETL tool that you'll have, or let's say you'll typically have things like shippers, right? They call it the shippers, or the probes that basically connect to the endpoints, and they basically send data to your monitoring stack. So I think those are the ones that make sure that once the raw data is in place, then you have the right templates to get it into the level of details that you want. But definitely it's something that is a very critical, let's say, part of the solution, to making sure that you get it in the right level, so that you get the right insights, you get the right dashboards created to give you the decision making abilities. But definitely, Chris, that's a process which will take which the heavy lifting is done by some of the products that we have, be it open. So I can tell you about Splunk because I've worked on that in the past. But definitely some of the products which are also on those similar lines. It actually, let's say, the elk stack, they definitely have those templates. So there's the element of at least 3 or 4 different, let's say, solutions that we have. We have it from different hyperscalers. Be it Azure has its own solution around observability. We have the similar solution that we have in AWS. Then there is the open source, let's say, solutions that provide observability. There is Splunk, there is Elk Stack, etc. And then there are these ISV products. So there is Dynatrace, and there is App Dynamics, there is New Relics, etc. So all these actually, my view is actually all these products are getting they're converging. I'm sure at some point, if you note, some would have some elements which are basically, let's say, provide elements which might not be present in the other solutions or the others ISV products. But definitely, I think if you see the importance of that capability, the other product vendors would try to replicate that solution. That's the typical sort of nature that we have. So a lot of these are converging, but it really depends on what strategy you have as part of your solution. If you're looking for an open source based solutions, then you have the Splunks and you have the Elks. If you're looking at an ISV solution, then you have Dynatrace, New Relics, App Dynamics, etc., etc. And then you are specifically, if you let's say building solutions for cloud native applications, then you have the Azure solutioning, Azure monitoring solution, or you have the AWS or the Google solution. So that's where we have there's a lot of, let's say, options that you can select from. But ultimately, I think your solution stack more or less will have the same capabilities. That the data pipeline, as we call it, or the underlying reference architecture would still remain same. And I can tell you definitely based on my experience working on some of these for our opportunities, definitely there is a lot of, let's say, materials or references that are provided that actually gives you the reference architectures, the various building blocks that are there, and how you can actually then customize and adapt to your own requirements. So a lot of things are already there, but it's quite an interesting domain, Chris.
Yeah, and I guess where my mind jumped to when you started mentioning about different vendors and tools and pieces available there is also the Cloud Native Compute Foundation. There's a few interesting projects over there, like Open Telemetry, I think Open Trace, and others as well. And like you say, I can imagine that there's almost going to be that interface, if you like, of, this is kind of like the protocol or the common standards, and then we just kind of base upon that standard. That seems like an interesting direction for things to go, for sure. Yeah.
Absolutely, Chris. Open Telemetry, the CNCF has actually published a standard for observability, and that's exactly what has been leveraged and what the vendors are leveraging to make sure that they are aligned with their standards and best practices. So they have provided a framework to make sure that if you're building an observability solution, it should comply with these norms and these best practices. So that's definitely what is coming out. And if you are actually going through these some of these artifacts online, I'm sure you would know. But that's the benchmark, Chris. That's the benchmark. So you have that Open Telemetry standard where all these ISVs and solutions are, I'm sure they would want to comply with that, because ultimately that's what we'll have to actually abide by. Because I think ultimately the client or customer would come back to us saying, look, we want our solution to be compliant with CNCF Open Telemetry. But I think it's still early days. I'm sure there would be development done. There would be a lot of changes that will happen, but definitely that's the starting point. It was not there a while ago, Chris. It has just come up. So I'm sure there's a level of changes that will happen in the next few years on that Open Telemetry framework part.
Sure, gotcha. Good. Okay, so we've kind of established that observability is almost a family of these different areas. And even the CNCF, I like how they group observability and analysis. They've got different sections for like monitoring, for logging, tracing, chaos engineering, of course, which is a good topic as well, and then continuous optimization. So it really is this suite and this family of different focus areas. So, where do we take the discussion from here, I suppose, Samir? Where do we focus next?
I think what I can do is I can actually walk you through the solution, just a solution architecture. I think the other things we have just discussed on the call. So I just wanted to walk you through the solution. So Chris, can you go to slide number 10? I think it's slide 10.
So I think if you bring up your slides there, Samir, and then I can go and share the screen. Then that's it.
I just wanted to. Yeah, I think I just wanted to.
There we go. One. Perfect. Yep, it's on screen there.
Yeah, all right. So I think this is basically the reference architecture, and as we've been discussing, right? I think this is basically the data pipeline that we have. On the left side, what we have is the distributed applications, which will consist of all your application nodes, right? Let's say your databases, your application servers, your web servers, integration touchpoint, the integration tooling. You'll have all the elements basically. That will basically be part of your distributed app, and it can as well be part of your on-premise or your cloud on your cloud platform. And then what we have is the first block here. The first vertical block is basically the data ingestion and collection. So that's what basically is where you will have the let's say shippers let's say, getting the data or ingesting the data from your distributed applications into the observability platform. So this forms the first touch point of the observability platform. And then what it does is it ingests all three elements of the framework, right? Open telemetry. So there's a logging data, there is a tracing data, and then there's a matrices data as well. And these are basically the raw data that is coming into your observability platform. And then the next part is where you do the processing of it, right? So I think if I have to elaborate this part, it actually will be three stages of your or three stages as part of your processing or aggregation. So first stage is where you basically have stored the raw data which is coming in from the distributed application. The second stage of it is basically where you are actually doing the cleanups, making sure that the data is in the right quality and the right standard. And the fourth stage of that particular processing stage is to make sure that the data is aggregated in the right form. So I think we'll make sure that the data aggregation is an important element, because I think it makes sure that before you derive any insights from that, that's where you'll do the feature engineering. That's where you make sure that you'll have the right tags implemented, so that when you run the analysis and machine learning algorithms, you have the data in the right semantics, in the right format that you want. So this is basically the three stages of aggregation. The next stage is where you do the AI and machine learning. That's where you will do the pattern discovery, making sure that if there are any anomalies that are there in your data, that will basically be picked up by this particular capability. Then you have the root cause analysis as to why it has happened, right? What is the reason why a certain issue that has popped up has happened? So that is the root cause analysis part. And then event correlation is something that basically makes sure that the entire tracing that you have, the call stack that you have, it will basically be made sure that it is integrated to derive insights and decisions for you. And the last stage is the stage where you get the notifications and your alerts in the form of reports and dashboards. But what's also important is this is basically that's what they call it, the self-healing infrastructures, where you will typically have that entire feedback loop implemented. So once they once you get an issue, which is let's say which is basically pinpointed, or which is basically analyzed by the solution, it basically updates the service tool, which is your ServiceNow or the service management tool, and also notifies the service days. Right, and then the service days will actually sort of have making sure that it makes sure that the ticket is analyzed, and then the entire auto correction is then triggered via this feedback loop here. So then that makes sure that this basically is corrected, or you make sure that any issues that you have, any anomalies that you have, is taken care of. So I think this is basically the self-healing infrastructure. The tools that I mentioned about, most of these tools are built on this kind of a reference architecture. So it has similar capabilities, similar, let's say, services that it implements. And then I think this basically is not part of the platform. So this particular thing needs to be provided and integrated into your entire solution, so that it becomes a self-healing infrastructure. But Chris, I just want to go to the slide number 22 and just wanted to walk you through what exactly is a self-healing infrastructure. So there's a slide that explains that. So I think over here, I think if you see, right, without the observability stack that you have, let's say when a problem is detected, the auto ticketing will basically make sure that the ticket is raised in ServiceNow, and then you have the level 2 support, which basically will manually triage what exactly is the ticket about, and then it will send it to level 3 support, which does the remediation. So it can be as simple as, let's say, restarting a virtual machine, right? But this basically, if you see, that timeline is about 60 minutes here. So if this is something that so this is basically something that is without the observability stack. Now, let's say you have a solution that implements the observability stack, and then this is the second, let's say, a diagram, that depiction that we have. It basically, when you have the observability stack, this is exactly how the process flow would look like. So we have the problem detected here. Right, the second stage is the auto ticketing, and as was depicted in the slide earlier, this auto remediation is something that is done by the stack. So if it, let's say, if it analyzes that there is a virtual machine that has gone down, so definitely what needs to be done is part of your rule. So which is basically then triggers making sure that you restart the virtual machine. So if you see this total difference between the time frame, it's really significant, right? You can't have a business application going down for 60 minutes. You have to make sure that if it goes down, right? It has to be up and running within a fraction of a second or within a few seconds. So this is this is what the use case it basically defines it. But I think you can extrapolate this for other, let's say, issues that you may have as part of your solution, meaning any bottlenecks, any issues. And again, this is just one solution where we are saying a virtual machine has issues and it needs to be restarted. But if you are looking at, let's say, a predictability capability, then it will analyze the data and make sure it, let's say, triggers a corrective action. So you can build those rules in your solution to make sure that you have this kind of a self-healing infrastructure in place. And what the beauty of this particular thing is, this basically everything that you see as part of this auto remediation, it can be built using your Ansible solutions like Ansible, right? Which is basically an infrastructure as a code framework. So Ansible is basically an open source solution. We have ARM, which is Azure Resource Manager, which is again on the lines of Ansible only, but it's basically more native to Azure. So we have these solutions which are called as infra as a code, which can be leveraged to build these solutions, will make it enable the auto remediation. And Ansible or ARM is something like which can handle your entire infrastructure through this particular framework. So you can have it deployed, you can have it configured, so I think there are various things that you can do with your load balancers, your let's say app servers, your proxies, your integration, let's say tooling, etc. So this is basically kind of very versatile tool that we have. So Chris, that's probably what I wanted to quickly show in terms of what exactly is a self-healing infrastructure and what you can do with the various tools that are there. Ansible being, or ARM being, some of the critical ones if you have to implement something like that. So that's
awesome.
about it, Chris, on the architecture front. Yeah.
Awesome. Thank you, Samir. And I guess as we start thinking about wrapping up and closing the discussion here, I think there's some really great insights in terms of observability, how it differs to thinking about just monitoring. It's a bit like a superset almost, is what I'm hearing and seeing. What would maybe be some of your tips and tricks? Someone's listened in here, they've gone, right, actually, we need to go beyond monitoring, as your talk title says. We need to think about observability now. Where do they start? How do they get going? What would maybe be your top 3 tips?
Chris, I think it has to be incremental in nature. So I think the first thing that they should do is to basically make sure that they at least have some elements of observability up and running, making sure that you have the POV, point of proof of concept ready, to make sure that you might not want to integrate the entire, let's say, application landscape into it, but definitely start small and then build incrementally. So I think definitely a lot of engagements that I'm working, a lot of opportunities that I'm part of, most of the customers around the world have adopted Agile and Scrum. So it has to be incremental in nature. So once you are actually part of a kind of a setup where you are actually, let's say, leveraging Agile Scrum, then eventually you will have the right sprint backlog, the right product backlog created. So first you create the product backlog and then you have the sprint backlog. So once you have the sprint backlog, you then decide what exactly you want to do. So once you start with, let's say, incrementally building it or a POC, then you add on to what additional capabilities that you may want to, let's say, embed into your solution. And then make sure that you have the right level of maturity as part of the stack. But Chris, what also is kind of very interesting is the fact that we have a lot of solutions already in place. So there's a lot of work that needs to be done to analyze what the existing tooling stack is, what are the existing processes or the methods that they are following, and then making sure that they reach the right level of maturity. So I think while discussing it with the CXOs, while discussing it with the business users in terms of making sure that they have the tooling stack that really caters to their business needs or business goals and objectives, that is also important. But definitely it helps to understand and analyze the existing tooling, because I think we are at a stage, Chris, where there are solutions already in place. So they are doing something or the other around observability. So making sure that you understand what that is, making sure that you leverage, you just not just knock off everything out, making sure that you leverage some of the good things in there and make sure you build the right capabilities and right solutions on top of it, and incrementally build that as an MVP, as a minimum viable product, and making sure that reach a level of maturity that is required as part of your as your business has been basically as required by your senior X in the organizations.
Excellent. Marathon, not a sprint. Great. Thank you, Samir. Really appreciate you coming onto the show and talking about this really great session. So thank you for joining.
Thanks, Chris, and thanks for inviting me here. It was a pleasure talking to you, and definitely I look forward to another such interesting session in future as well. Thank
Sounds
you.
good. Thank you. So there we go, folks. We've been talking all about beyond monitoring and thinking about this idea of observability. So the applications we build are a lot more complex. There's distributed applications, there's different services, potentially even different platforms, some in cloud, some not in cloud. We then, as end users, obviously have higher experiences or higher expectations, I should say, as well. And ultimately, then that influences those business metrics, things like reliability, scalability, performance expectations, etc. So observability helps us understand end to end what is going on in that platform. And rather than trying to find out which haystack the problem is in, being able to pick the needle straight from the haystack and come up with that optimal solution really quickly there. So really great session. Some lots of great things to explore there as well with different providers and some of the options there from the Cloud Native Compute Foundation as well, of course. So thank you for tuning in there, folks. Hope you have enjoyed. Do let us know in the comments your thoughts and where you are on your observability journey. And until next time, thank you for tuning in. And bye for now.